So a lot of these concepts we have already covered just as a result of doing that interface example. So the idea of reference variables. Why is car called a reference variable?
Because it's referencing a different method, right?
Not that it's referencing a different method. It's that when this thing happens and an object is made, this references that object, but you could have multiple references to the same object. You could make car 2 and set car 2 equals to car, and then you have 2 references to the same object.
Okay.
So each reference variable has inside of it a memory address that's pointing to the object that it's pointing towards. So here we have a class named car. Until we actually assign it a value, car is just pointing to null or saying it's uninitialized or whatever. Once we do new car, then out in memory, an object is created, and then that variable contains, not that we can read that number, I think it's supposed to be 1062. It points to that memory address out in memory. So that's how, behind the scenes, when you say car.year, it finds the specific year. What it does is it hits your reference variable. It goes, oh, that's pointing to memory address whatever, and then it goes to memory address whatever and finds that particular member or method and monks with it. So if you assign one reference variable equal to another, both reference variables point to the same object. And my example for that is always 2 signs that point to the same store or whatever, you know. It's the same store, you just have 2 different signs for it. Or I could say, you know, you have a secret identity for a superhero. Both Clark Kent and Superman are really the same person. With both reference variables pointing to the same object, if the object is updated by one reference variable, the other reference variable notices that change. So if you say car1.name equals Ford, and then you say car2, print car2 out, if they're pointing to the same object, it will also say Ford. That can be disconcerting. I don't know how disconcerted we get once we understand it. So, car Stacy's car, car John's car. John car is equal to new car. So we make it a Toyota, a silver one, and then we say Stacy car is John car. Maybe she bought an identical car, so we thought we could save time by doing that. And then we say set color peach. Well, if we print out all of the items, the make and the year and the color, both John car and Stacy car are going to say that it's a Toyota, it's 2014, and that they're both peach. Probably not really what you want, but you know, Clark Kent got a mohawk, that means that Superman got a mohawk too. It's the same thing. So, a practical example of how this might get you. What if you had an array list of objects, but all the elements actually pointed to the same object? Which you could do if you weren't careful. Now, every time I've demonstrated an array list, we haven't had that problem, but we could write some code that will. Let's make a itty-bitty little object called student. So all I did is make a new Java application. We could add a student class to it, and the student has a name and a whatever, school. So here we're going to make a student. Student S is equal to new student. So s.name is equal to Joe Bob. S.school is OSU. Then let's add this to an array list. An array list of students. Array list student. I'm just going to call it slist is equal to new array list, like that. It doesn't know what an array list is. We'll add the import. Now let's add that student to the array list. So slist.add my student. Now say we had an output series where we printed out, inner student name, and then we, printed out inner new student or student's new school and that kind of stuff. And what if we did this? S.name is equal to Jill Bob. S.school is equal to OU. And then we add that student to our list. You probably already see the problem here. Now let's write a loop that will print that list information out. For student, well, we can't use S, we already used S. ST in slist system.out.printf %s/n, comma st.name, comma st.school. So what we did is we've created a class called student up here at the top. We created a new student. We gave him a name and a school. We made an array list and added that student to it. Then we changed the name and the school, and we added that to the array list. I'm removing spaces now to get all this to fit on the same page. Then we had a for loop to print it out. Run it now and see what it prints. What do you know?
They both got a mohawk.
Right, both of those reference the same object. We added the same object twice. So we only have one student object out in memory. We just changed the name, changed the school that pointed to. So no matter how many times we add that to the object, it's still the same object. So whatever the last values we set in it are the ones that get picked up when we print it out. We have multiple references in this thing, in this list, to the same object. As far as slist is concerned, it doesn't care whether we're putting new objects in it or references to the same object or whatever. It doesn't care. So we have wound up with an slist that contains multiple references to the same object. That's why when we printed it out the same information for both students. Because they're not both students. They're the same object, just being printed twice. Just like if we had done slist.add s here, and then slist.add s here, we'd have two, with the same name. And then if we turned around and we changed this after we had added both of them, it would still print the newest information out. Hope that makes sense. Another thing we need to talk about is, and you can stop me if we have already talked about this, whether Java is pass by copy or pass by reference, and what that implies when you pass in an object as a parameter. Does that sound familiar territory, or I'm seeing you kind of go,
I think it does, but I'm not sure if
How about
it's
y'all
from
three?
here.
Does that sound like new material or boring rehash? Okay, alrighty. So, comments. Java is a pass by value, also known as pass by copy. language. So is Python. C++ and C# support pass by copy, but they also support something else called pass by reference.
Maybe that's what I'm thinking of, since I'm doing Python this semester too.
Okay,
So.
okay. So, what that means is that if you write a function, I'm just going to switch to Notepad now, temporarily. If you write a function that looks like this, void change me, and you pass an int in, and then x gets changed to something else. So down in main, you do this. Int age is equal to 20. I'm 20 years old. Now change me. And then print age. You don't have to type all this in unless you're typing in the notes. There we go. What is it going to print? Is age 20 when it prints it out, or is it 10? If it was passed by reference, then it would be 10. You know, this actually changed it. But it did. This is a local variable that gets filled in with the contents, with a copy of this value. This actually is not that variable. X is not age, it's just a copy of it. It's a local variable that got a copy of it. If, for example, you did it like this, I'm going to rewrite this just a little bit. Temp is equal to X, and then temp is equal to 100. If you did that, and you passed age in, would you expect age to be 100 by the time this is done? No, it's just changing the value of some temporary variable. Well, that's all that X is, really. It's a local variable that gets a copy of this. So it gets a copy of that variable. You can change it and do whatever you want to. It hasn't touched the original variable. That's what's known as pass by copy or pass by value. That's the parameter. That's the argument. The parameter gets a copy of the value of the argument. In C++, you can use pointers to get around that. You can also use a symbol that declares, oh, by the way, this is really a reference variable. And in C# you actually use the word ref, I believe. You say ref int x. Now there's a very good reason to make it pass by reference, even if it seems like it might be inconvenient. What if you did this? I'm going to undo those last changes, and I'm just going to say x is equal to 10. What if you did this? Change me 40. Would it be fair to expect the value of 40 to somehow miraculously become 10? What does that even mean? 40 is a constant. It could not possibly be changed. Java is passed by copy. A lot of times, that continues to make sense when we think about things. Well, no. Forget what I just said. What if we had another version of change me that changed to student? Void change me student s. And whenever we call change me, s.name becomes Tony. That's enough. So down here in main, apparently our program has multiple mains. I'm kidding. Down here in main, when you make a new student, not a student, a student, and you give that student a name, s1.fred, and then you call change me on that student, and then you print that student's name out. What do you think it's going to print? Wait, what in the world is this s1.fred? I'm sorry, guys. I'm on antihistamines, and they've broken my brain. Here we go. There. So before we pass the object in, the name field is set to Fred. This turns around and changes the name field to Tony. When we print it out, is it going to print Fred or Tony? You might think that just since I went up here and said, it doesn't change it to 10, it's still a 20, that it's still going to be Fred. And in this case, it is not. It becomes Tony. Well, why is that? You said that that's a copy of what get passed in. But what is this reference variable really? Think back to that first PowerPoint slide. It's just an address. We're passing an address into here. And so it goes to that address and changes it, which means that when we print it out here, it's been changed. So here in this example, let's put some comments. Prints 20, because Java is pass by copy. So when change_me tries to change x, or does change x, it's just a copy of the value of the age variable. Here, down here, this actually prints Tony because S in change_me gets a copy of the value of the S1 variable, but S1 is a reference variable to a specific memory address. So change_me changes that memory address. So the change affects the original data. Hope that makes sense. It's not like you're going to fail the course if you don't understand that, but if you go on to do programming in C or C++ or Python, Java, it's worth understanding what pass by copy versus pass by reference means. Python is a pass by copy, so it behaves just like Java in that respect. C# and C++ also support pass by reference. So if you really wanted to, you could pass 20 in, and it would change it to 10 and print out 10. But you do that by modifying the way you declare the parameter. Are we good? Cool. Anybody need to finish typing in this code?
I have a question about my code.
Sure.
It's saying my student class, that student has already been defined.
Well, let's
Might just be an error that shouldn't be happening. I might have to just restart the program.
well, that's got to be a So if you have something like that, if you have a function called foo, and you want this thing to actually be able to change the radius, and you want main down here to be able to do something with that, you know, foo, you pass in x, and then you want, you know, to be able to do something with a radius. How do you get that 400 out of it? Out of the function. Changing is no good because by the time you're done with foo, that 400 is gone. I can think of 2 ways. 3 ways. So I'm sure there are hundreds. What would you do if you wanted foo to be able to set a value or let the user type it in and get that value back to main so that you could do something with it? You're allowed to do anything. You can rewrite this in any way you want. I'm going to glare at y'all on this. Somebody comes up with a way. You want this program down here
Right.
to be able to do something with a 400. What do we normally do in order to get values back from a function?
Return.
Yeah, a return. That's the easiest way. Just return radius. So if you wanted to do that, you could do this. And this is a common programming technique. Return radius. And then down here, you just do x is equal to foo x, you know? Like that. So int x is equal to 100. That's probably that's a really common way. What if we made a member variable or a class variable that applied to both methods? That would work as well. What if we did this? Class my class int radius. You wouldn't be passing a radius in. You wouldn't need to return it. I don't know what I just did there. There we go. You know, radius is equal to 400. And then when you did this, after you called foo, then you could do something with the radius. Like that. Two ways to get data out of it. The third way would be to make radius part of a class, because you can pass an object in and have it change the members of the object. We already proved that in the last example. What you cannot do is allocate a new object in it. If we go back to this code, and we did this, S is equal to new student, and that student has a name of Tony, then when we print that out, is it going to print Tony or Fred? You can probably guess just by the way I've set up this question. The other way worked. This way doesn't.
So it's gonna
Why?
print Fred.
Because that's a copy of this, but we just set it equal to something else. It no longer points to the same memory address. Now S is pointing to a new memory address as opposed to that one. So yeah, you can make any changes you want to. It's like you made, whatever. So this would not print out Tony. It would still print out Fred because this created a new object. If you wanted to get this object back here to do something, you would need to return S and then say S is equal to change me. That clear enough? Clear as mud? 50%? 70%? All right. I'm going to copy all that and paste it as a new example. I'm just going to say prints Fred. I'm not going to even explain why. Because change me allocates a new object and then applies changes to that object, not the original. Not the original object. Testing objects for equality. If you wanted to test two students, you cannot do if S1 equals S2 or equal. Why? Because all that's doing is checking to see if they point to the same memory address. Maybe that's all you want. Maybe you want to see if two things are a reference to the same address. But what if you want just to check to see if the two students have the same username and ID? Or if you want to check to see if two squares have the same height? Or two circles have the same radius, and that's the condition that makes them equal. Well, then just checking to see if they point to the same object isn't going to work. Just like when you'd have string 1 equals Jeff, string 2 equals Jeff, and then you do if S1 equals F2, S2. Is that going to be true or false? Probably false, because S1 and S2 probably point to different memory addresses. So even though the contents are the same, they point to different memory addresses. So you cannot do this. If car1 is equal car2. Car1 is equal to new car, car2 is equal to new car. They both have the color red. Are they the same? Print out the same, else print out different. It's going to print out different. If you want to compare them, you better compare car1 dot color is equal to car2 dot color. Or better yet, write a equals method. Let's go back to our student class in our code. public Boolean equals. And when you're comparing it to another student. I'm just going to call it other. So we want to check to see if the students' names and the students' schools match. If this dot name dot equals, can I spell, other dot name, if that's equal to false, then return false. If the name doesn't match. Then we're just going to do the same thing for the school. If this guy's school dot equals other dot school is equal to false, return false. Else, return true. We're not going to put else. There we go. Now we can check to see if two objects have the same contents, not merely the same address. You might have two people who are both wearing black glasses and blue shirts, and you might decide that's enough to say they're the same. What's the question?
Why does it say the if statement is redundant in the if this school equals other school?
Oh, really? Yeah, you could rewrite it like that. It does the same thing. I disagree with writing it like that. I think that makes it harder to understand. If you stare at it and understand why those are the same, great. If you look at that and go, why? All it's doing is that since if this is true, it returns a false, else it returns a true, they're shortening it to one return statement. Just like if you did this. Don't type this. If x1 equals x2, or not equals x2, return false, else return true. You see that one? You could rewrite that just to say this. Return x1 equals x2. Those mean the same thing. You see why? Okay, so this one, the syntax is more gnarly, so it looked harder to understand why it was offering to do it. But that one's pretty clear. All right, let's make a couple of students and compare them. So go up to main. I guess we already have one named Joe Bob, but student me is equal to new student. Me's dot name is equal to Jim. Me's dot school is equal to Rose. Now let's make another student. Student U is equal to new student. U dot name is equal to Beth. U dot school is equal to OU. And then let's just print out whether those match or not. Boolean match is equal to me dot equals U. And then system dot out dot print line match equals end quote plus match. They do not match, so I want it to say false. Now change them so that both of them have the same information, so that you and me are the same. When you run it, it should say match is equal to true. So along with our other guidelines for writing classes, which because I love to state them over and over, I'm going to state again, we're going to put a dot equals method in your class if you'll be comparing them. So we're going to probably have 6 guidelines for classes or more. What are they? Data, private, methods, public, getters, and setters. Constructor, if it makes easier to use. Uh-oh. I'm only coming up with 4 there. Oh, toString. Add a toString to print data out. And lastly, add equals if you will be comparing objects. Then there are some ancillary, that's not how you say that, guidelines. A, each class in its own file. B, class name begins with an uppercase letter. That's more organizational, though, rather than contents. That's kind of why I've listed them as A and B. Everybody get the student match code working?
Yes.
Mine's code. I changed it to the same thing and it still had false.
Okay. Student rows, yeah, you're right. Did it work for other people? Okay. Make this line, just as a pure test, say if me dot equals me. Make this, change that you to me. It absolutely should be the same, right? So delete,
Just
me. Yeah, change that I or whatever that is to me. Parentheses me. Now we've got too many parentheses. But yeah, there we go. This absolutely should say true. If it doesn't, we've got a big problem. Okay. Why did that work and the other one did not? Oh, look. You're creating an object named me and you're filling it in, then you're creating an object named you, and they're all me's. So, me. Yeah, there you go.
Well,
Question? I'm just curious about this. Does that?
my mom wants me to.
Yeah, if you want to confuse yourself, you could do that. I don't even understand functional operators myself, so I
If she
don't.
wants me to wait a month
tell
just so she
students
can
to
do
do
it, it's
that.
not a weekday.
But you can do that, if that's your favorite way of stepping through a list. Not mine. Okay. This actually all goes inside the student class. So we're just gonna be adding this stuff. Capital S. They do match, but if we make this somebody else. Should say false, 'cause they don't match. You're good?
Yep.
All right. So if you're going to be testing objects for equality, don't use equal equal. Write yourself a dot equals method. Passing references as our objects. We've already given an example of that. If you pass a reference in, you can change the variables inside that object, and that'll stick true. But if you try to change that variable to a brand new object, that won't stick. Method call chaining. I honestly have never seen why you would want to do this, but we could. You know, I forget that. Okay, here's what they're trying to do. You know, we have our student thing here, and you know how to highlight those two lines and add setters for them, right? I don't care if you do this or not, because I think it's ridiculous. But anyways, highlight those two lines. Go ahead and do the refactor.
Yeah.
These setters are named void. But if you wanted to, you could do this. Make each one return a this pointer. Where's the other setter?
Down there.
Okay. Yeah. So make your setters return this pointers. Why? So you can have the satisfaction of doing this. U dot set name to Chuck dot set school to OSU. You ever feel like doing that? No. I don't. Okay, I'm not going to ask you any questions about that. If you want to be able to chain methods like that, though, just make sure that the methods you're chaining return the this reference. I guess that's worth adding as a comment.
Yeah, that just seems unnecessary.
Pardon me?
That just seems unnecessary, method call change.
Right, right. Overloaded methods. We talked about that on Monday, did we not?
Yes.
We know the difference between an overload and an override. Which one means replacing a method that was defined in a superclass?
Right.
Override. Which one means two or more methods that have the same name in the same class? That's overloading. Obviously, you could just guess the other one, but yeah. Overloading is two methods with the same name but different parameter lists.
We use them a lot of work, so.
Constructors. We know what constructors are. Do we need to talk about constructors again? We could write a constructor for our student object, which would take a name and a school. I dare you to do that. Go do that right now. Add a constructor to your student object that sets the name and the school. And I'll type it too, but pretty much at this point you ought to be able to do it yourself. A constructor is a method that has the same name as the object. So it's called student. It can accept parameters, string name, string school, and it sets the values of the instance variables according to those parameters. This dot name is equal to name. This dot school is equal to school. So one thing that I don't think this book shows is writing a clone method. Let's do a search on this PowerPoint and see if it does. What if you really wanted to be able to do something like this? I'm going to leave that constructor on the screen and just start a comment. What if you wanted to be able to do this? Student me is equal to new student, and this is Amy from OU. And then you wanted to do this, student you is equal to me, and have those actually be two different variables. Well, you can't with that syntax in this language. In C++, you can hack it to get it to work by doing what are known as operator overloads. You could overload the assignment operator to do whatever you want. Instead, you would want to write a clone method that actually returns a new student. So, public, it needs to return a reference to the student class. So public student clone, which just like that other one, takes a reference to a different student. So it has to make a student. I'm going to call it R is equal to new student. And we will pass in the other student's .name and the other student's .school as the parameters to the constructor. And then we will return that new student. So if you want the ability to be able to copy objects around, you may want to provide a clone method. Why do you care? Well, when you're sticking objects into a parameter, into an array list or something like that, and you feel like changing those values, remember that you're actually changing the things in that array list. You may wish that you could get something from an array list and then start modifying the values without it changing the original array list values, in which case you want those to be copies of the things in the array list rather than so that you could change it without changing the original data. Don't know if that makes sense. We didn't even show that being used. When we added that constructor, it broke our code. What do we have to do to fix it?
Change the way we're passing in those.
Right, we need to either pass in Jim and Rose as arguments to the constructor, or we better go back and add a default constructor that doesn't take any arguments. But let's go ahead and just do this. That needs to be Jim, comma Rose. That needs to be Chuck at OSU. And we probably have further errors down here. Yep. Joe Bob at OCU. OCCC, something, whatever. If you want, once you have a constructor, you can take out all the setters, which makes the data impossible to change once it's created. If you want to do that. Can't think of a reason, but if we did not want to be able to go back and reassign my name from Jim to being something else, then we would take away the setters. What is the keyword that calls the constructor of your parent object, of your superclass? I'm kidding. But say we made a class that extends student for whatever purpose. Class grad is extends student. I keep wanting to put parentheses. There's no parentheses involved when you're defining it. It's complaining because there's no constructor. The constructors do not match. This one has a default constructor, this one doesn't. This one has a parameterized constructor, this one doesn't. So we're going to make a constructor for the grad class that also accepts a name and a school. But here's what we cannot do. You may think you can, but you can't. Don't even bother to type this. This.name is equal to name. Will not compile. Why is that? Because we made the data private. That means that even these things, the subclasses, can't change it. If you want to make the subclasses able to change it, you go change that private word to protect it. Instead, we're just going to call the constructor for the superclass. So super name, comma, school. That calls the constructor that we made up there. So what keyword inherits from a superclass? What did we just use to make grad? Extends. What keyword lets a class I almost don't know what word to use that doesn't give the answer away. Use an interface. We didn't use extends when it was an interface. We used a different word. Anybody remember? Implements.
It's 2 years.
What was an interface? Is an interface an abstract class?
Yeah, it's a
Yes.
special type of that.
An interface is an abstract class with no non-abstract methods. So what is an abstract class? An abstract class is a class with abstract methods. Then what's an abstract method? An abstract method is
Abstract method
It doesn't have any, like,
doesn't have a body.
yeah, it just has something you need to make.
Right. An abstract method is one with no body. The body must be provided in a class that extends that abstract class. So an interface, when you say implements student, you're guaranteeing that you're going to go and create a class that has all the methods that that interface class specifies you have to have. What is polymorphism? That's a good definition, but in programming terms,
the behavior is different, what the data is different.
yeah. Let's see if he's got a fancy name for it here. Nope. We'll make one up then. Polymorphism. When you can call the same method and have different behaviors based on what type of data your object is. The classic example is sticking them all in an array list and then calling, get area or something like that, and then the method is different. Like when we put a get area method in a circle class and a square class. All right, guys, I think we're done for today. Let's see if we've already had a homework assignment this week. I think it was to watch the videos.
Yeah, it's another video tutorial.
We'll leave that there. Okay. All right, gang, I'll see y'all on Monday. Any questions?
Can you bring up the code real quick? I missed the last thing for the grad.
Sure.
Super, okay, so it really is just the word super. I started typing that in last
Yeah.
fade, so. There we go, cool.
So we could add a comment, calls the super classes constructor.